On the 7th of December 1995, we dropped something into Jupiter on purpose. It hit the top of the atmosphere at 47.6 kilometers per second. Underneath it, there was no ground. There never has been. This is Cosmion. Every world we have ever landed on had a moment where the falling stopped. The Moon had dust. Mars had rock. Even Venus, which destroys landers within hours, gave the Soviets something to stand on. Jupiter offers none of that. NASA puts it plainly. As a gas giant, Jupiter does not have a true surface. It is mostly swirling gases and liquids, and a spacecraft arriving there would have nowhere to land. Astronomers still need somewhere to measure from, so they picked a level and agreed to call it zero. It is the depth where the pressure matches sea level pressure on Earth. It is a bookkeeping decision, not a place. As for what it is made of, Jupiter's composition is close to the Sun's. It is mostly hydrogen and helium, the two lightest and most common elements there are. NASA puts it this way: Jupiter has the same ingredients as a star, but it did not grow massive enough to ignite. So the obvious next thought is to go through instead of down, fly in one side and out the other. That does not work either, and the reason is worth being exact about. The pressures and temperatures deep inside Jupiter crush, melt and vaporize any spacecraft that tries. 3 separate things happen to it, in that order, and none of them leaves anything behind to arrive anywhere. The missing floor explains something you can see from Earth with a small telescope. On our planet, a hurricane dies when it crosses a coastline, because the land underneath it takes its energy away. Jupiter has no coastline anywhere, so its storms are never interrupted. The Great Red Spot is a swirling oval of cloud twice as wide as our entire planet. We have been watching it for more than 300 years. The bands themselves come from speed. Jupiter turns once every 10 hours. That spin tears the clouds into the dark belts and bright zones you recognize. More than a dozen prevailing winds sweep the planet. At the equator, some of them reach 539 kilometers per hour. Those winds blow across a planet with no ground underneath to slow them. The colors may be a clue about what is underneath. NASA says the vivid tans and browns may be plumes of gases containing sulfur and phosphorus, rising up from the warmer interior. If that is right, the surface we can see is already showing us the inside. There was a reason people were watching Jupiter closely in the 1990s. In July 1994, a comet called Shoemaker-Levy 9 broke apart and struck the planet, and Galileo was close enough to watch it happen. It remains the first, and so far the only time anyone has directly observed a comet colliding with a planet's atmosphere. The fragments hit, and the atmosphere closed over them. There was nothing for them to land on either. Which brings us back to the thing we dropped. In October 1989, the space shuttle Atlantis opened its cargo bay and released a spacecraft called Galileo. It took 6 years to reach Jupiter. Galileo was carrying a passenger. Bolted to its side was a squat cone about the size of a kitchen appliance. It was built for one job that it could only do once. It was an atmospheric entry probe. It was the first entry probe ever sent into the atmosphere of an outer planet. Nothing had ever tried this at Jupiter, Saturn, Uranus, or Neptune. There was no previous attempt to learn from. They let it go on the 12th of July, 1995. From that moment, the probe was on its own, with no engine, no steering, and no way to change its mind. It then coasted for nearly 5 months. On the 7th of December, it arrived. The probe met the top of Jupiter's atmosphere at 47.6 kilometers per second. That is 106,000 miles an hour. It worked. The probe survived the entry, opened a parachute, and began sending measurements back up to the orbiter waiting above it. For the first time, instruments were reporting from inside a gas giant. And then it stopped. The pressure and the heat did what they always do. The probe was crushed, melted and vaporized exactly as NASA describes for anything going deeper. Here is the part that reframes everything. That probe did not get anywhere near the interior we are talking about. It died in the weather. Everything below it is still unvisited, and always has been. Galileo itself lasted much longer. It orbited Jupiter for years. Then, in September 2003, NASA deliberately flew it into the planet to destroy it. That way, it could never fall on Europa and contaminate the ocean it had helped discover. Nobody watched it happen. On the day of impact, Galileo's radio signals took about 52 minutes to reach Earth. By the time we heard the last of it, the spacecraft had been gone for nearly an hour. So let us do what no machine has managed. Let us keep falling, past the point where the probe stopped, and see what the physics says is waiting. First, the size of the thing we are falling into. When the sun had finished forming, Jupiter took most of what was left. It ended up with more than twice the combined material of every other body in the solar system. And the fall would not feel like falling for very long. You would not accelerate cleanly downward through empty space. You would be moving through thickening material that pushes back harder the further you go. The first thing that changes is not the temperature. It is the weight of everything above you. On Earth, the whole atmosphere presses down with about 10 tons on every square meter, and we never notice. Jupiter is 11 times wider than Earth and has far more atmosphere stacked above any given point. As you fall, that stack grows above you, and there is no ground below to end it. The pressure simply keeps climbing. Squeeze a gas hard enough and it stops behaving like a gas. The molecules are pushed so close together that they can no longer move freely past each other. What was air becomes something you could swim in. The other thing that changes is the light. Jupiter sits 5 times further from the sun than we do, so it starts out dim. Then the cloud closes over you and takes the rest. It gets hotter, and for a reason that has nothing to do with sunlight. Squeezing anything heats it up. The pressure that is compressing the hydrogen is also raising its temperature, and both keep climbing together all the way down. That is what happens inside Jupiter. Deep in the atmosphere, the pressure and temperature rise until the hydrogen gas is compressed into a liquid. There is no splash and no shoreline. The air just gradually stops being air. NASA has a name for what that liquid adds up to. They call it the largest ocean in the solar system. Not the largest ocean on any moon, and not the largest we have visited, the largest there is. And there is not a drop of water in it. Jupiter's ocean is made of hydrogen. It is the same stuff that fills the atmosphere above it, squeezed until it runs. Nothing floats on it, because there is no surface for anything to float on. You would not arrive at this ocean. You would simply notice, at some point, that what you were falling through had begun to behave like a liquid. Keep going, and roughly halfway to the center, something happens that has no equivalent anywhere on Earth. The pressure becomes so extreme that it starts stripping electrons off the hydrogen atoms themselves. Loose electrons are what make a metal a metal. They are why a copper wire carries current and a plastic one does not. So when the electrons come free inside Jupiter, the liquid starts conducting electricity like a metal does. Now put that conducting liquid inside a planet that spins once every 10 hours. Moving a conductor generates electrical currents, and enormous currents are exactly what is thought to be circulating down there. This is where Jupiter's magnetic field comes from. The spinning metallic hydrogen is thought to act like a dynamo. That dynamo generates the planet's powerful magnetic field, and it is made of nothing but squeezed gas. Nobody has photographed any of this. The ocean, the metal, and the dynamo are all worked out from measurements taken from orbit. They also rest on physics we can test in a laboratory. That distinction matters for what comes next. It is worth sitting with how strange that is. Hydrogen is the lightest thing in the universe, and the gas we put in weather balloons. Squeeze enough of it together, and it starts conducting electricity like copper wire. The pressure needed is far beyond anything in ordinary use. That is why the inside of Jupiter is one of the few places we know this material exists in bulk. The largest sample of it anywhere near us is a planet. There is one more thing worth saying about that ocean. Nothing lives in it. NASA is careful with the wording, but the conclusion is plain enough. The temperatures, pressures, and materials are most likely too extreme for anything to adapt to. Which leaves the center. If you learned about Jupiter at school, you were probably shown a diagram of its layers. Right in the middle sat a small hard ball, colored differently from everything else, labeled core. That picture had good reasoning behind it. The theory was that Jupiter is a mostly uniform mix of hydrogen and helium. That mix wrapped around a small solid core of heavier material. The core was ice, rock, and metal, gathered there 4 billion years ago. But we have already established that nothing can go down and look. So how do you check what is at the center of a planet you cannot enter, cannot land on, and cannot pass through? You weigh it, not the whole planet, but every part of it separately. A spacecraft in orbit speeds up very slightly when it passes over a denser region and slows very slightly over a lighter one. Juno has been doing exactly that, orbit after orbit, along with mapping the magnetic field the metallic hydrogen produces. Between them, those two measurements describe how Jupiter's mass is arranged from the cloud tops all the way down. The core is much larger than anyone expected, and it is not solid. It is partially dissolved. There is no clear separation between the core and the metallic hydrogen surrounding it. The heavy material is mixed into the layer above rather than sitting beneath it. Researchers have a word for it. They call the core dilute, or fuzzy. It is worth being careful here because fuzzy does not mean absent. There is heavy material down there. What is missing is the edge. It matters because the solid core was supposed to be the seed. The standard account of how Jupiter formed begins with a lump of ice and rock gathering enough gravity to pull in an atmosphere. That lump should still be there, intact. It is not intact. Something either stopped it forming cleanly or dissolved it afterwards, and we do not currently know which. The oldest part of the largest planet in the solar system is the part we understand least. Think about what a dissolved core means for the rest of the planet. Heavy elements are not locked away at the bottom. They are spread through an enormous volume of conducting hydrogen, mixed in rather than settled out. None of this was visible from a photograph. Every image of Jupiter ever taken shows the same thing: cloud. The interior had to be worked out from how the planet pulls on a spacecraft passing overhead. Reasonably confident and honestly uncertain in the right places. NASA says the data suggests a dilute core. Suggests is doing real work in that sentence, and it is the correct word for a measurement taken from thousands of kilometers above. Which brings us back to that small cone falling through the clouds on the 7th of December, 1995. It was heading for a center that, as far as we can tell, does not have a place where it begins. Jupiter is not a world with its surface hidden under cloud. It is a world where the question of a surface never comes up. Gas thickens into liquid. Liquid starts conducting like metal, and heavy material fades in without ever arriving. The largest planet in our solar system has no floor, no shoreline, and no clear center. It is 11 times wider than Earth, and there is nowhere on it or in it where you could stand still. And all of that, the ocean, the metal, and the missing edge, is what Io is orbiting. The planet doing the squeezing turns out to have nothing solid at its own center to squeeze from. Subscribe for the next investigation. We are going to Europa. The moon Galileo was destroyed to protect.